para may copy kayo after the class. If you want to eat your breakfast, that's fine. Uh, Feel free to do so. Okay. So let us begin our chapter 2 discussion. Okay. So we're going to talk about atoms. Why? Because atom make up the it makes up the matter that is around us, 'di ba? Sabi natin last time, matter is anything that occupies space and has mass, no? And our understanding of matter, no, na-prove natin that yeah, they are made of atoms indeed, no? And even in our body, no, in humans, most of our body atoms, no, ay gawa talaga sa sa mga elements, no. Okay, for example, majority of our body gawa sa oxygen. Saan kaya galing yung oxygen na yon? So probably galing yan sa water. Okay, probably galing yan sa water, the carbohydrates we eat, no. Ano pa, sa mga amino acids, may mga oxygen doon. Meron din sa nucleic acids, no? Even sa DNA, may mga oxygen doon. So, yan. That's why most of the mass of the person is attributed to the oxygen's mass. Okay? And then, followed by carbon, obviously, we are organic. We are a product of organic chemistry. So, yan. So, gawa tayo sa carbon. And this is the building block of many molecules in our body. For example, the proteins, no? The sugars in our body, gawa yan sa carbon. Okay? And then hydrogen, usually tandem talaga yan with oxygen and carbon. Okay? And then nitrogen, this might be found mostly in amino acid and nucleic acids na. Okay? So, puro nitrogen dun. And then yung others are the other non-essential elements such as the phosphorus in the phosphates. We have the potassium to maintain homeostasis in our blood. No? The sodium. No? Ayan. So, yun yung mga ibang elements. Okay? So now, alam natin that matter is made of elements or they are made of atoms. No? But before, our understanding of that, hindi natin alam yan. Okay? Lalo na yung mga nabuhay noong panahon ni Jesus Christ. No? They don't have any idea what we are made of. No? Okay? So now, let's take a short history discussion muna. Okay? So let's take a look into the short history of the development of atomic models or atomic theory. Okay, so the idea of atom actually dates back before Christ era, right, or before Common Era. That is in the time of Democritus na. Pero bago ako dumiretso kay Democritus, may isa-segue muna ako na si Aristotle. Okay? So si Aristotle, he is one of the philosophers at the time that theorized na that everything around us is made of fewa. O kung PUP ang kayo dati or may kapatid kayo or may friends kayo from PUP, alam nila yan, fewa. Footlong egg wrap around. Anyway, so sabi ni Aristotle, no, everything around us is made of fewa, no? The fire element, the earth element, the water element, and the air element. Kaya baka isipin yung joke ko, hindi, totoo yan. Okay? Na ito nga yung basis ng ange. Okay? Yung concept ni Aristotle. Okay? So yun, Aristotle thought that everything was made of these elements. No? Okay? So for example, if you plant a tree, and then later on you make it a wood, now, since yung tree galing sa earth, that means the wood is made of earth elements. Okay? So, ganun lang. Ganun lang kaisa yung concept niya. Okay? So, kunwari, nagtanim ka ng, fruit-bearing, na halaman. Okay? For example, mangga. So, that means, yung mangga, that is made of earth elements because it came from the ground. Okay? An example, water. You have the rain, you collected the rain, and then you drink it, no? Ganun kasi dati. Ibig sabihin nun, yung urine mo, that is made of water elements. Okay? Kasi galing yan sa tubig na kinolekta mo from the heavenlies. Okay? And then yung air, that is the thing that you cannot see but you can feel, no? Okay? For example, Christmas. Hindi. For example, yung hininga natin, ayan. So, they thought that, yeah, that those are made of air elements. Okay? And then yung fire, um, in our current understanding, fire is not really an element. No? Rather, it is just the light emitted when atoms react to one another. Pero before, they thought that fire, no, is composed of tiny glowing particles. No? But currently, hindi ganun yung understanding natin. Okay? So, yan. So, yan yung concept ni Aristotle. However, that was contested by Democritus, no? Our main guy in science. So Democritus is one of the many philosophers at the time, no? But his approach to understanding matter is very different, no? He thought that when you divide certain objects, no, you will come to a point that you can no longer cut it. Okay? For example, kuha akong papel. Sabi dito, stop violence against women. Okay? This is from the Vauci. Okay? Ayan. For this paper, I will cut it into two and then I will continue doing so until hindi ko na siya makat. Okay? So, ayan, isang buo, hatiin sa dalawa, hatiin sa dalawa, dalawa, dalawa. Anong papansin nyo? Edi obviously, lumiliit na. However, the tinier it becomes, no, the harder it is for me to cut it. Okay? Ay, eto, medyo nahihirapan na ako. Yun, okay. Pahirap na ng pahirap. Wait lang. Yan. Ito yung gusto ko sa topic na to. Nagpupunit ako ng papel. Okay, so ayan. Medyo nahihirapan na ako. Ayan na, nahati ko pa siya. You cannot see it anymore, pero ito siya, ang tiny paper. Okay? So, if you continue doing that, according to Democritus, no, you will come to a point that you can no longer cut it. No, that Greek term they use. Okay, that Greek term they use is the atomos, no? Because literally, what atomos means is uncuttable. Okay, so yun yung concept ni Democritus. Continue cutting objects, and then they will become smaller, and then you will come to a point na hindi mo na siya makat. Okay, hindi mo na siya mahati. No? So yan, that's the first concept of atoms, no? Okay, which literally means in Greek, indivisible. Okay, so yan yung idea nila. Okay, pero ito, sino yung nagwagi na? Is it Aristotle or Democritus? Obviously, it's Aristotle. Aristotle muna. Because one of the primary reason is that Aristotle is very famous, no? And actually, mas kilala nyo nga si Aristotle kaysa kay Democritus, di ba? Okay? In social science, Aristotle is very known, no, to produce many ideas, no, in establishing republic, no, in politics, in democracy, no. So lahat ng mga ganong kaalaman, they all came from Aristotle. Okay? So, ibig sabihin, since Aristotle is more influential at the time, Democritus' idea was kind of moved away from the history. Na parang na-brush off siya. Okay? So, yan. So, yun yung idea, no? That si Aristotle, famous, Democritus, hindi famous. So, na-set aside siya. Okay? And only until the time of John Dalton. Okay, I will skip that slide kasi mamaya na yun. Okay, so only in the time of John Dalton, around 15th or 16th century, I'm not really sure kung alin doon. Okay, so only at that time of John Dalton, they proved that Democritus was indeed correct and Aristotle's idea was a joke. So, ibig sabihin, no, it took a while for them to realize, no, mga thousands of years pa until ma-prove nila na Aristotle is not correct when it comes to science because the scientific experiment states that Democritus is indeed correct. No? Okay? So, sino yung nagpatunay that Democritus was right? Okay? It was John Dalton, an English chemist. Okay, so at the time of John Dalton, they were able to do chemical experiments. No? So kumbaga, chemistry was born na. Okay, however, the understanding of chemistry is still little. So pero ang mahalaga, meron na silang experiment at the time, okay? So yun, John Dalton, together with other people such as Proust, no? Um, yung Lavoisier, no? So sila, naggagawa sila ng mga independent experiment, and then they found out that the ideas presented by Democritus is analogous with their observations, no, compared to Aristotle's, no. Okay, so ginawa ni John Dalton, he collated all the ideas presented by other scientists at the time, no, and he made the atomic theory. Okay, and that is yan dyan siya na credit, no, sa atomic theory ng matter. Okay, so in his atomic theory, there are several postulates, no, and I would like to somehow describe all of them, no, ano yung pinaka-point ng sentence, okay? Again, you don't need to memorize this. All you have to do is to just get the point, okay? Kung ano yung meaning nun. And number one, all matter is made up of tiny indivisible particles called atoms, okay? And that is the same as what Democritus hypothesized, no? So sabi ni Democritus, if you cut objects into much smaller pieces, you will come to a point that you cannot you can no longer divide it, no, and that is called the atomos. Okay, so yan, John Dalton adopted that idea, no. Okay, because again at the time may experiment na. Okay, so na-prove nila na yeah, um, Democritus was right. Okay? So, yan. So, sinabi nila, they claim that the atoms are the single component of all forms of matter. Okay? A second statement is that atom of a given element have the same chemical property. That also means that atom of different element behaves differently. Okay? And that is obvious until now. For example, if you put sodium in water, pag yung sodium nilagay mo sa tubig, it explodes, no? Sumasabog yung sodium. Okay? May explosion na mangyayari. And the atoms of sodium is very different with that of iron. Kasi kapag nilagay mo yung iron sa tubig, mangangalawang yan, no? Hindi siya sumasabog. Rather, it's turning into rust, no? So, ibig sabihin, if you have different elements, then they behave differently, okay? So, ikutin mo lang yung sentence ko na yan, you will come up to a conclusion that atoms of the same element will have the same property. Kasi, ang logic is that kapag magkaiba sila ng element, iba yung behavior. Ibig sabihin, kapag same sila ng element, same yung behavior nila. Okay? So, yun yung workaround na ginawa sa sentence number 2. Okay? So, yun. So, atoms of the same element behave similarly. Okay? Number 3, in ordinary chemical reaction, no atom of any element disappears or is changed into an atom of another element. Okay? So, ito yung sinasabi nila ng law of conservation of mass. Okay? So, ito yun. That according to the law of conservation of mass or law of conservation of matter, that matter cannot be created nor destroyed in any chemical reaction. Okay? So, what just happens is that they rearrange, no? Kung sino yung kapartner nila before, after the chemical reaction, hindi na sila magkakapartner. Okay? For example, I burn this paper. Okay? Pag sinunod ko tong papel, yung atoms ng carbon dito, which is bounded on hydrogen and oxygen, mababind lang siya sa tawag doon. Mababind lang siya sa oxygen in the air, producing carbon dioxide. Okay? So that means, wala naman talaga na walang atom. Basically, nag-change lang sila ng partner, okay, during chemical reactions. And yeah, that's given by the law of conservation of mass. Okay? So yun. So that is true, no? So kaya dito pumapasok yung lesson natin in the future, yung stoichiometry. Okay? Yun yung mathematical part, no? Pero sa laboratory yan i-discuss. So yun, in this topic, makikita natin that atoms, no, before the reaction should be equal to the number of atoms after the reaction. That's why we have to balance the equation dahil dito sa statement na yan. Okay? So yan. On number 4, we have compounds are formed by the chemical combination of two or more kinds of atoms, no? Ito statement na to, this is a summary of the two other laws determined beforehand, okay? So itong mga laws na to, these were determined before uh, John Dalton made his atomic theory, okay? Kumbaga, meron ng individual experiments. Ang ginawa ni John Dalton is he collated them to further prove that there are atoms, okay? So ano ba yung meaning ng sinabi niya dito, no? Na yung ating atoms of different elements or of the same elements, if they combine, no, they form compounds, no? And their combination has definite proportions or sometimes multiple proportion, okay? So ibig sabihin nun, if for example, if water in creating water, there should be 2 hydrogens to 1 oxygen, no? So ito yung ratio niya, 2 to 1 hydrogen to oxygen ratio. If you alter that ratio, then you are pertaining to a different compound. For example, 2 hydrogen, 2 oxygen. Okay, so ano yan? That's hydrogen peroxide, which is deadly, no? Hydrogen peroxide is used by lysosomes, no, to kill the cell, okay, in the process called apoptosis, di ba? Okay, so something like that. Okay, and sometimes we use it to disinfect our blood, our wounds, blood tuloy, to disinfect our wounds, di ba? Okay, so yeah, as you can see, there are defined proportions, no, for every compounds, no, and altering that proportion leads to a different compound. Okay? So, ganun. Yun lang yung idea niya dito. He combined the law of definite proportion and the law of multiple proportion. Um, yun. Pinagsama niya lang yung ideas doon. And then, lastly, a molecule is a tightly bound combination of two or more atoms that act as a single unit. Okay? So, ang idea niya dyan is that when you combine atoms, they form molecules. And the molecules behave as one unit, no? It behaves very differently from its precursor. For example, the sodium and the chlorine gas, no? If you combine the atoms of sodium and chlorine gas, you will form sodium chloride. And the behavior of this molecule here, of this ionic compound here, is very different from its precursor. Okay? So, yung asin, hindi siya deadly, no? Okay, maalat siya. Pero kapag yung sodium, nilagay mo sa tubig, sumasabog yan. Yung chlorine, nakakamatay yan, no? Okay? So, yan. So, they act as one and they behave very differently from their precursor. Okay? So, another example. Another example. Hydrogen gas is explosive. Oxygen gas causes combustion. But water is used to put off fire. Di ba? Okay. So, ayan na. So, kikita niyo yung contrast na ng kanilang properties. No? Because the way this molecule acts is very different from its precursor. Okay? So, yun yung mga observation nila. Okay? Okay, so again, in development ng ating atomic history, we started with Aristotle with his Phewa, okay, in the fire, earth, water, air. And he theorized that lahat ng bagay gawa sa ganyang elements, sa apat na elements. No? And this is the basis for Ang. No? Okay? Alam nyo yan. Okay. And then, that was contested by Democritus. Sabi niya, this is the more logical process. However, since Aristotle is very famous, edi naset aside si Democritus na. Until the time of Dalton, dun lang siya na-prove na tama si Democritus na. Through series of experiment that led to these laws here, no, John Dalton was able to come up with a general statement on atoms. Okay? At the time kasi, no, if you're a scientist, no, pag pinagsama-sama mo yung idea, sisikat ka talaga. Okay? Just like him. Okay? Pero of course, he did a lot of experiments as well, no, to further prove that, no. Because before, when you theorize something, you will be heavily criticized by many people, no. Okay? Ganun yung pagiging scientist dati. Ngayon kasi pag nag-publish tayo ng research, yun na yun. May tatlong reviewers lang, no? Reviewer 1, reviewer 2, reviewer 3, then publish paper kung okay. Before kasi, yung buong society, ay i-judge ka. Ay, we're talking about hundreds of scientists around Europe at the time. Okay? So, yun. However, yung atomic theory ni Dalton, that is actually good, no? But when technology improved, no, we discovered more about atoms, no? So that means we somehow need to modify some things in his atomic theory, okay? So again, okay na yun. Okay na yung kanyang ginawa. Pero there are things that needs to be modified, okay? Because our understanding of atoms now was very different with their basic understanding. Na. Basic lang kasing pagkakaalam nila. Tayo, we have more advanced technology no, to understand the atoms, okay? Pero yeah, we still credit John Dalton because at the time, no, his predictions was correct, no? So, may ano yung mga minor modification na ginawa natin, okay? So, una is that not all atoms of an element have precisely the same mass, okay? So, ito yung sinasabi niya na uh, yung atoms ay identical, no? So, ito yung counterpart nun. Bakit? Um, in late 1800s, early 1900s, no? Okay. Nauso yung radioactivity, no? And in radioactivity, they found out that there are elements of the same, there are atoms of the same element that behave very differently, no? Yun yung tinatawag nating isotopes, no? Okay? So for example, hydrogen has three isotopes, no? The protium, the deuterium, and the tritium. Okay? Protium, deuterium, and the tritium. Okay? So yun, wala pa kasi lang alam sila about radioactivity, but in the late 1800s, no, we have an idea na, okay? So that means we have to modify yung sinabi niya na atoms of the same element must be the same, no? Not really, because there are isotopes, no? Okay, so these are atoms of the same element, but they somehow behave differently, and they have different masses, no? For example, protium is not really reactive, no? But deuterium and tritium, no, are radioactive, no? Tritium can emit beta rays, no? So, ganun. Yun yung idea. Okay, so yan. Yeah, they behave very differently, although they are the same atom. So, yun yung minor modification. Also, because of the discovery of radioactivity, na disprove din natin yung sinabi niya na ano, um, teka lang, nawala ako. Sakit lalamunan ko eh. Okay. So, ayan, na-disprove natin yung idea na chemical reactions lang yung pwede mangyari sa matter. Okay? At the time of John Dalton kasi, the only thing they know is that chemicals react, no? Okay, through chemical reaction. Ganun lang. Chemical changes, no? However, at the time of modern era, na-discover natin yung radioactivity and we can really convert atom of one element to another atom. Okay? So, parang ito yung concept ng alchemy, ano? However, we call it now the nuclear science, okay? The nuclear chem. Ano yung focus ng alchemy? Kung nanonood kayo ng mga Code Geass, di ba may ganun doon. The goal is to find the philosopher's stone, no? Parang siya, that is an element na pwede maging gold, okay? And pag nakagawa sila ng gold, yaman sila, okay? So, bale, in the previous times, no, in the time of John Dalton, walang ganung idea, no. Sabi lang nila, yung carbon after chemical reaction, carbon pa rin yan, okay? However, through the help of nuclear chemistry, we were now able to know that we can really convert elements, no, okay? But hindi siya chemical reaction, nuclear reaction yan, okay? So for example, in our star, ganito yung nangyayari. Yung hydrogen na convert to helium, and that is converted into boron, and then carbon, okay? And then oxygen, and then neon, okay? So yan, all the way up to iron. Okay, so this is called the alpha process. Okay, okay. Alam niyo yan siguro sa physical science, no? The triple alpha process, no? Yan. Ayan, yan. Sa nuclear chemistry yun. That you can really turn one atom into another atom, no? Into another atom of another element. Okay? So yan, that's the minor modification. However, yan. However, we can still credit John Dalton as to be mostly correct. Okay? Ano pa? Ito, the composition of many solid compounds are somewhat variable. Ano yan? For example, in sodium chloride, no? Hindi talaga yan one-to-one, no? Okay? Because we have now a concept of crystal lattice. This is actually a quite difficult topic, no? Okay? Pero hindi natin di-discuss yan. Hindi naman kay BS kami, no? Okay? So, for example, in the crystal lattice of sodium chloride, hindi naman talaga one-to-one yung ratio niya, no? There are many atoms of sodium surrounding chlorine atoms, no? Okay? So, hindi siya one-to-one yung ratio talaga. Okay? It is something else, no? Other than one-to-one, okay? And then lastly, ayun, this is nuclear reaction, that you can split atoms, okay, into smaller particle. Nuclear reaction. Okay? So ito yung ginagamit na concept sa nuclear power plants, no? So in nuclear power plants, uranium are converted into thorium and alpha particles. And that thorium will continue to decay to produce lead, no? And during the process, high energy is being emitted, no? And that energy is used to boil off water in order for the generators to pump electricity. Okay? So ganun lang. So that's the development of atomic theory, no? Okay? Pero hindi pa tayo tapos. We are still here, eh. Okay? Ang dami pa tayong kikilalanin tao. Okay? So again, review tayo. Phewa kay Aristotle, Atomos kay Democritus. Famous si Aristotle, so siya yung nanguna. Si Democritus, hindi siya famous, so sinet aside siya. John Dalton, through chemical experiments, na gumawa siya ng atomic theory, proving that Democritus was right. However, at the current time, there were some modification in his theory. Kasi may mga inconsistencies siya, no, as our technology improved over time. Okay? So now, let's go to the modern era. Okay? So ito 15th century to 16th century. Punta na tayo sa 1800s, no. At the time of J.J. Thomson or Joseph John Thomson. Okay? So noong time ni J.J. Thomson, they have electricity. Okay? May kuryente na. And then ano yung una mong gagawin sa kuryente? Sa isip ni J.J. Thomson, kuryentehin yung atoms. Very weird. Okay? Pero ganun siya as a physicist. No? So ginawa niya, in his cathode ray tube experiment, he have a metal atom here. Okay? So I don't know if what metal is that, pero I think that's iron. And then dinugtong niya sa kuryente. Okay? That time pa lang nagkaroon ng kuryente. Okay? Then, what he observed is something weird, no? Pag kinuryente niya yung atom, he suddenly saw a beam, no? A beam emitted by the atom. So, ibig sabihin, nagtaka siya, no? Bakit kaya may tumatalsik sa atom pag kinuryente ko siya, di ba? So, naisip niya that, that particle emitted by the atom probably has charge, no? So, ginawa niya, nilagyan niya ng magnet, no? Positive, negative. And he found out that it is attracted to the positive plate, no? So it bends toward the positive side. So that means the particle emitted by the atom when it is electrolyzed, no, electrocuted. Teka lang, lobat ako. Ayan, okay. So the idea is that the particle emitted by the atom is attracted to the positive. Therefore, it must be negative, no? So, nag-isip siya ng mga idea, no? He consulted many scientists as well, no? And then he proved that the particles emitted by the atom can be called electrons, okay? So, the electrons are negatively charged particles that are emitted by the atom, no? Bakit siya na-emit? Kasi ganito yan eh, no? The electrons are embedded on the surface of the atom, no? Okay? So, baga, you have the atom, you have the electron surface here. Pag kinuryente mo yan, tatalsik sila. Okay? So, yun yung idea na ginawa ni J.J. Thomson. Okay? So, yan. Na-prove niya yan. Okay? And for that, he actually won a Nobel Prize in physics, I think, na. So, nanalo siya ng Nobel Prize in Physics, okay, for the discovery of electrons. Okay? So, ayun na. Ayun na. So, 1910 pala yun. Okay, so he proposed the plum pudding model. What is a plum pudding? That is a food, that is a delicacy in England, okay? Na ano yan, parang may raisins, okay? So, inisip niya, pag kinuryente mo yung tinapay, yung raisins tatalsik, okay? So, that's analogous with the atoms, no? The electrons will shoot out, no? Ayun lang. Okay, so anyway, so that's the atomic theory, you know. So, nag-improve yung ating tsura ng atom, no? So, at the time of John Dalton, bilog lang yon. However, at the time of, of J.J. Thomson, ano na siya, may details na. Okay? Also, we have to take note that in J.J. Thomson's plum pudding model, meron na tayong concept of the subatomic. Okay? The subatomic, atomic, pero smaller than that. Okay? So, that means electron is a subatomic particle because it is smaller than the atom itself. No? Siya yung nasa loob ng atom. Okay? So, nagka-idea tayo that atom is not just a circle, rather it is a circle with raisins on it. No? May electrons sa ibabaw niya. Okay? So, that's the plum pudding model. Okay? And then, na-discover nila yung radioactivity with the help of Madame Marie Curie and her husband, no? Her husband, si Pierre Curie. Silang dalawa, mag-asawa sila. They do research on radioactivity. However, si Madame Curie ang primary proponent for that. So that's why siya yung kilala talaga. Okay? Pero si Pierre, partner in life niya talaga. Sana all na may ganong partner. Research sila sa experiment din. Ayan, partner sila sa research. Okay, so ano pa? Other than Madame Marie Curie, we have Roentgen in physics, and then we have ayun, so all those people. Okay. So with their help, no, na-discover natin yung radioactivity, no. So Ernest Rutherford thought that why not try to imitate J.J. Thomson's experiment but with radioactive particles, okay? Kasi tingnan niyo, no, kay J.J. Thomson, ang ginamit niya to excite the atoms, no, or to excite the electron of the atom is kuryente. Okay? Pero at the time of Rutherford, meron ng radioactivity. So ginawa ni Rutherford, he got the radioactive particle that emits alpha rays, okay? So this one emits alpha rays. Then kumuha siya ng gold foil, okay? And then pinatamaan niya yun ng alpha ray, no? That is somehow similar with this one, no? You have a metal sample here, then kinuryente niya. Dito naman, may metal siya na gold, binombard niya ng alpha ray. Okay? And then, naglagay siya ng circular coating dito. Okay? Ayan. And then, binombard niya yun, di ba? So, kapag tinamaan ito ng alpha ray, it will glow. This part will glow. Okay? So, and this part will glow, and yeah, it glowed, no? Pero, something weird happened, no? Okay? Actually, they were frustrated at the time, no? Kasi wala silang makitang bagong discovery. However, nung pinatay nila yung ilaw, may napansin sila, no, na hindi lang pala yan yung spot, no? Hindi lang pala ito yung spot ng alpha particle. When they turned off the lights, nakita nila that some of the light actually glows here, no? It glows here, no? It glows at an angle that is different with the linear angle here, no? Okay? So, parang may nag-bounce off, may nag-reflect. Yun yung idea nila. Okay? So, taka sila, bakit ganun? Kasi supposedly, ang makikita mo lang dapat talaga is the straight line. Okay, ito lang dapat yung spot na yun. However, in reality, nung pinatay nila yung ilaw, nakita nila some of the spots were observed at a very different angle. Okay? At this angle, at that angle, this angle, that angle. Okay? Nagtaka sila, no? There's something inside the atom pa pala. Okay? Because they know that alpha particles are positive. And only when it hits a positive particle also, it will deflect. Okay? So, di ba, alam nyo yun, yung magnet, pag parehas positive, what will happen? They will deflect, di ba? Okay? They will deflect, no? Magbabounce off sila. Okay? Ginagawa ko yun sa, dati sa ref yung magnet. Pag positive parehas, ganun mo, wala, maghihiwalay talaga yan, no? Okay? So, ganun yung logic na ginawa ni Rutherford, no? Probably, the positive alpha particle hits something positive in the atom, okay? So may natamaan siyang positive, no? That when it hits that positive particle, it bounces off or sometimes it gets deflected, no? So that's why you see spots at a different angle than this line, okay? So yun, he was able to theorize that the atom is made of, is mostly an empty space, no? Kasi majority of the line, majority of the spots can be found here, no? So that means mostly empty space ang atom. However, in the center of the atom, there is a positive particle in there, and he called it the nucleus. Okay, itong positive center na yon, he called it the nucleus. Okay, which is a tiny dense material that is positive, no, and the electrons are circulating around it. Okay. So yun, so that is somehow different with J.J. Thomson's model na. Kasi sa model ni J.J. Thomson, yung ating atom itself is the positive, no. However, at the time of Rutherford, yung atom mismo hindi siya talaga malaking positive na bilog, no. Rather, it is an empty space with the small positive center in it, no. Okay? Ayan. Tignan nyo to, no? Ito dapat yung kay J.J. Thomson. Kung positive mismo yung atom, ayan, mag-bounce-bounce lang. Pero, what he discovered is that may small center doon and the electron, and the alpha particles passes through it, no? Okay? So, that's the idea of Rutherford, that the atom is made of something positive inside it, no? And he called it the nucleus. And nanalo siya ng Nobel Prize again in physics. Okay? So, yan. In-improve niya lang yung ginawa ni J.J. Thomson and nanalo siya ng Nobel Prize. Okay. So, what's with James Chadwick naman, no? Some of you might be familiar with his name, but I think mostly are not, no? Okay. So, what's with James Chadwick, no? James Chadwick looked into the nucleus stated by Rutherford, no? Kasi sabi niya, 'di ba, yung nucleus positive 'yon, okay? Okay, maraming positive 'yon. Why is that those positive particles in the nucleus doesn't repel each other, okay? O, 'di ba dapat totoo 'yon? Kasi alam natin yung magnet, pag pinagdikit mo yung parehas positive, they repel, 'di ba? Okay. So, um, ibig sabihin, dapat nag-repel yung nucleus ng atom. We should have disintegrated over time, no? Okay, kasi yung positive center, they should repel, di ba? So, ginawa niya is that he take a look into the nucleus itself, no? And then he found out that the nucleus of the atom has something else pa pala, no? Other than the positive particles, na-discover niya that there are neutral particles, no? Called the neutrons. Ayan. Tawag doon ay neutrons, no? So, ano yung analogy ng neutron? Okay, so imagine nyo, you have two magnets. They repel each other, especially kapag pareho sila positive. However, lagyan mo ng unan sa gitna. Will they repel? Hindi na. Okay? So, yung magnet, yung unan sa gitna, hindi, that serves as a cushion, no, for the protons, no? Okay? For the positive particles not to resist, no? Okay? Not to reflect one another, no? Okay? So, yun yung idea ni Chadwick, no? That neutrons exist in order to provide cushion for the for the positive particles in the nucleus, no? Okay? So yan. And that's why we don't disintegrate, no? Hindi tayo nasisira, no? Kasi may kasamang neutron yung protons, okay? And that serves as the boundary or the cushion, okay? That protects them from repelling each other. Okay? And nanalo siya ng Nobel Prize diyan, okay? So Chadwick was accounted for the discovery of neutron, the neutral particles, and then pinangalanan nila yung other particle na positive as the proton. Okay. However, the discovery of proton is still uh, given to Rutherford na. So siya pa rin talaga yung naka-discover ng proton kasi siya yung naka-discover ng positive nucleus, no. Okay. Hindi niya nga lang alam na may kasama pa pala yun. Okay. So, yun. So, pinangalanan ni Chadwick yung kasama nun as the neutron. Then, yung proton, yun yung positive. So, binigay sa kanya yung credit pa rin. Okay? So, yan. So, Chadwick is a good guy. No? Kasi, hindi niya inangkin lahat ng credit. No? So, he still gave credit to the previous researcher, no? Rutherford. Ayan. So, yan lang. And then, dumating na yung time na may dilemma na sila sa science, no? Because there are things that cannot be explained at the time. Okay, for example, pag kayo, di ba may takuri kayo sa bahay, huwag nyo lagyan ng tubig, no? Especially kung manipis yung takuri nyo. Initin nyo yung takuri na walang tubig. What will you see at the bottom of the takure? Di ba? It will glow red. Di ba? Lahat ng bagay kapag ininit mo, nag-glow siya as red. Hindi ma-explain ng physics yon at that time. Bakit sila nagkukulay red? Okay? Na kapag yung object ininit mo, it glows red. Okay? Taka sila na sabi nila, hala, paano yun? Even Einstein cannot explain that. Okay? Buhay na si Einstein at this time. Okay? Sabi niya, hindi nila ma-explain to, bakit ganito? And then, meron tayong newcomer. Si pangalan niya si Niels Bohr. Okay, isa lang siyang bagets that time, no? He was 23, no, when he proposed this idea. And imagine nyo, ako 23 nung ginagawa ko sa buhay. Okay, di ba? Ang grabe yung mga isip nila, no? They really dedicated their entire adult childhood, no, to science. Okay. Pero yeah, that's how it works. So yan. At the time of Niels Bohr, no, he tried to explain, no, why things glow the way it is, no. Okay. And by the way, yun yung ito yung concept sa experiment niyo. Okay. In experiment number 2 sa laboratory niyo, okay. Yan yung concept ng flame test, okay. So anyway, bahala na sila mag-discuss doon. Okay, so ginawa ni Niels Bohr, he tried to explain why objects glow when heated, no? Okay? And since hindi yun ma-explain ng classical physics, gumawa siya ng panibagong physics that's called the quantum physics, no? Or the quantum chemistry. Anyway, tandem naman yung physics chem always, eh. Okay? So imagine nyo, no? Pag wala kayong masagot sa isang bagay, gumawa ka ng panibagong field of science. So ganun sila ka-brilliant, okay? So, Niels Bohr actually did this ganito na he theorized that atoms are not just these things na ganyan-ganyan lang, no? Okay? He thought of the electrons of an atom occupying certain energy levels, okay? So, sabi niya, yung ating atoms, no, yung electrons doon, they occupy certain energy level. And when they are heated, they actually bounce, okay? Nagba-bounce sila. Okay? So, look at this, no? When the electron is heated, it bounces, no, from one energy level to another. And look at what it creates. It creates waves, no? And we know that waves is a form of light, di ba? It is a form of light. Okay? So yun yung na-discover niya, no? That the jumping electrons between energy level produces waves, and that waves can be seen as light. Okay? Yun yung kanyang idea, na that the electrons orbit the nucleus in distinct energy levels, okay, or quantized yun, in a certain energy levels, and that when they bounce off from one energy level to another, they create waves, no? And these waves can be observed as colors in our eyes. Okay, so Yeah, that's true, no? Correct yan. Kasi yun yung reason bakit ganun nga natin nakikita yung ating objects when they glow, no? They glow red because the electrons are jumping, no? And the wavelength they produce matches the color red, okay? Ganun yung idea ni Niels Bohr. However, at the time, no, since Niels Bohr is a newcomer, no, bagong tao lang siya sa physics relatively compared to Einstein, Maxwell, um, all those classical physicists, no. Um, he was heavily criticized, no? And even Einstein said na napaka-ridiculous niyang tao, okay? He was committing fraud. Parang ganun yung mga sinabi nila at that time. No? Imagine, no? Masabihan ka ng ganun ng ano ni Einstein mismo. However, Niels Bohr stood to his ideas, no? And then later on, until this time, we use Niels Bohr idea. Okay? So that proves that even though you are smart, no, it doesn't mean na always correct ka, no? Because you have to be open to new ideas, no? So yun lang yung naging problem with Einstein, no? Okay? So yeah, he's a great scientist. However, he was close to some ideas, no? Kaya ayun, wala siyang naging ambag dito sa new field of science, sa quantum physics, okay? So yeah, that was one of the greatest blunder in Einstein's history. Yeah, he's great pero hindi natin makakalimutan dapat yung side na against siya dito sa quantum physics, which was actually found to be very accurate, no, in describing atoms. Okay? So yan, yan. So doon nagkaroon ng divide sa physics, no? The classical physics and the quantum physics. Okay? So yan, later on, they accepted that Niels Bohr was correct. Okay, in 1927. Pakita ko yung picture sa inyo. In 1927 Solvay Conference, doon napatunayan that Niels Bohr is indeed correct. Tignan nyo yung itsura ni Einstein. Kasi naka-sad face siya. Ayan. So this is the Solvay Conference. Ayan. So I'm very sure nakita niyo na to. Wait lang. Okay. So ayan, tignan niyo yung mukha ni Einstein, no. Ayan. Ito si Einstein, no? Sad yan. Okay? Malungkot siya dyan kasi talo siya. Okay? And then si Niels Bohr, teka lang, hanapin ko. Wala, hindi ko makita si Niels Bohr. Basta nandito siya sa likod eh. Okay? So ito si Einstein. Ito yung mga classical physicists. Talo sila dito sa mga baguhan na quantum physicist na. Okay, so that means na although you are smart, no, that doesn't mean na you're always correct. No? You should be open to new ideas, no? Especially if that can be proven by experiments. Okay, so yun yung ginawa ni Niels Bohr. No? He theorized that the electrons of an atom occupy certain energy levels, no, the orbits, no. And when they bounces, they give off certain wavelength of light, no? And that is observed during flame test. Okay, so alam nyo na isasagot nyo sa flame test. Okay, and then we will proceed lastly with Erwin Schrödinger. Okay, so Schrödinger, you know this Schrödinger equation, yan yon, H psi equals E psi. Okay, okay. So that's his equation. Ano lang ginawa dahil dito? He improved the idea of Niels Bohr. Okay? Because there are problems with Niels Bohr idea din. No? Although, yeah, correct siya dyan. Pero may certain problem, no? May konting issue lang. Okay? So, he tried to resolve that problems, no? Using statistical approach, no? Sabi ni Schrödinger, yung ating electrons, they are not really found in orbits, no? Hindi talaga yan circular orbits. Rather, they can be found in clouds of electron probability. Yes, they still bounce off, pero hindi siya orbit talaga, no? It is in the clouds of probability. Okay? Naka-cloud yung itsura ng atoms. Okay? So sabi niya, this is wrong. Mali yan. This is correct. And until now, we still use this idea, okay? That the atoms are clouds of electron. Okay? Okay. So may clouds ng electron dyan, and in the center you have the nucleus. And depending on the type of orbital, no, iba-iba yung itsura ng cloud. You have the spherical, the s orbital, the dumbbell, the p orbital, the clover leaf, the d orbital, and yung f orbital I can no longer draw it because it's too complicated. Okay, so that is the product of Schrödinger's equation. Okay? So, hindi naman niya completely dinebunk si Niels Bohr. Basically, he just improved on the idea of the location of electron. Because dito na pumasok yung Heisenberg uncertainty principle that you cannot really determine the location of the electron. So that means you cannot really find it in orbit. Rather, it can be found in the cloud of probability of electrons. Okay? So that's why ganyan yung itsura ng ating atom. Okay, so that's the history of atomic theory, and until now we still use a Schrödinger equation to predict the structures of atoms, no, to look into their behavior. Ayan. So lahat ng mga yon ay dahil sa tulong ng quantum physics na. Okay? And yun, as a chemist, no, inaaral talaga namin yan. Okay? Very mathematical approach yung ginawa ni Schrödinger, which was very contested by Einstein. Kasi sabi niya, no, hindi yan de-describe ng math. No? But in reality, yes, it is. No? Okay? So again, quickly, let's go through the names. No? Okay? Kasi tapos na tayo sa first part. So, Aristotle, ano meron sa kanya? Aristotle, he theorized that everything is made of the elements, no? The four elements, the fire, earth, water, air. Okay? And then Democritus, he theorized that everything is made of the atomos, the tiny indivisible particles. Ito yung tsura ng atom at this time. Then, that was proven to be true by by John Dalton. Okay? John Dalton made several experiments together with other colleagues, no? And then they found out, yeah, um, Democritus' idea is good, no? In explaining why chemical reactions behave the same way, okay? Or behave that way, okay? So still, ganito yung itsura ng atom at this time. Pangalan nito, si J.J. Thomson, kinoryente niya yung atoms, and he found out that the atoms are made of much tiny particles, no? Negative particles called the electrons, okay? And then yan, he called this model the plum pudding model, okay? And then si Ernest Rutherford, the next person after him, Ernest Rutherford, ang ginawa niya is that instead of using kuryente, he used alpha particles, no? So he bombarded the gold foil with alpha particles, and then he found out that the atom looks like this, no? Ito talaga yung itsura ng atom, no? Wherein you have a positive center, and then the electrons are just moving around your nucleus, okay? And this is mostly an empty space. So yan yung ginagamit ni Jimmy Neutron. Okay? And then kay Niels Bohr, malitong model na to. Okay? For Niels Bohr, ang kanyang discovery is that the electrons of the atom are actually moving in orbit na. Okay? Just like planets. No? That's why he called this model the planetary model. Okay. So yan, planetary model yung itsura ng kanyang model of an atom. Because the electrons bounces off here and then they produce certain wavelength of light. Okay. And that was improved later on by Schrödinger. Okay. So Schrödinger made several equations. No? Ito yun, H psi equals E psi. Ayan. So he made those equations in order to describe the probable position of the electrons. Okay. And he said that the electrons are in clouds, no, orbiting the nucleus, not in orbits talaga. Naka-cloud siya. Okay? So ayan. And yan yung ginagamit natin until this time. Okay? Okay, so ang galing, no? Very young, especially si Niels Bohr is a very young person, pero ang dami niyang naambag sa buhay. Okay? Ako, kasing edad ko siya noong nag-prove siya ng ganyan. Kinalaban niya si Einstein. Tapos ako, ano ginagawa ko sa life ko? Tayo. Nanonood ng TikTok. Nagbabalo. ML, ganun. Anyway, so magkaiba na kasi yung scenario natin na. Okay. Anyway, so let's take a look into the representation of the atoms na. No? Okay, so this is actually the wrong model. This is the nuclear model by Rutherford. No? Pangalan ng model ni Rutherford, nuclear model ha. Okay, so this is the nuclear model of an atom. Bakit ito yung gagamitin natin? Okay, so tama si Schrödinger pero medyo mahirap i-visualize. No? So ganito na lang. We use the nuclear model by Rutherford. So in this model, we know that the nucleus is inside and the electrons are just moving around in clouds. Okay, okay, ayan. And then, based on Chadwick and Rutherford's discovery, the nucleus of the atom is made of much more tiny particles called the proton, in which si Rutherford yung nakadiscover niyan, and si neutron, which was discovered by Chadwick. Okay? And yung mga physicists natin, they try to determine the mass, the charges of the subatomic particles, and then they found out that the most of the mass of the atom can be attributed to the components of the nucleus, no? So yan. So that means is atomic mass, no, is related to the protons and neutrons, no? Okay? Because sila yung mabibigat na particles at the time. Okay? Electrons are virtually walang mass, no? Masyadong maliit for it to have mass. Okay? Although they have, pero hindi siya ganun ka-significant. Okay? So that's the idea of the atomic structure, no? You have the proton, the positive particle, the neutron, which cushions the positive particles, the electrons moving around it, no? And then the mass of the atom is heavily concentrated in the middle. Okay? Proton and neutron. Okay? So andoon yung mass ng atom. Okay? You don't have to memorize all this, no? Ang gusto ko lang i-point dito is that the proton and the neutron has greater mass than the electron. Okay? So, ibig sabihin, the mass of the atom is in the nucleus. Okay? It is concentrated in the nucleus. Okay? We represent elements, no, in this manner. Okay? This is how we represent elements. This is called the nuclear symbol. Because this gives us an idea on what are the subatomic components of the element or of the atom. Okay, so in the nuclear symbol, you have the element symbol. So yung element symbol, yan yung nasa periodic table. And then you have the atomic number at the bottom. The atomic number tells you the number of protons in the nucleus. Okay, and for every element in the periodic table, you have you have certain atomic number. For example, hydrogen, it is atomic number 1, so that means it has 1 proton. Helium has an atomic number of 2, so that means it has 2 protons. Lithium is 3, 4, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, so on and so forth until oganesson, which is 118. Okay? So yan, for every atomic number, there's a corresponding number of proton, okay? And for every elements, they should have the same number of proton, okay? When we talk about mass number, ito yung number sa taas, it gives us an idea about the number of proton and neutron in an atom, okay? So that is the sum of proton and the neutron, okay? Kasi nga sabi natin earlier that the mass of the atom is the sum of the number of protons and neutrons kasi sila yung mabibigat eh. Okay? So yan. So that's why we have the mass number. And then, depending on the composition of your atom, you can have isotopes. No? When we say isotopes, we have the same element but different masses. Okay? Bakit kaya different yung mass nila? Probably because of differing number of neutrons. Okay? For example, we have here the isotopes of hydrogen. We have here the protium, deuterium, and the tritium. Tritium. So as you can see, they all have the same they all have the same number of proton, so that means they belong to the same element. Okay? Basta same number of proton, same element. But look at their masses, no? Their masses differ. Ito isa, ito dalawa, ito tatlo. Okay? So yan. So ibig sabihin nun, they are isotopes, no? Okay? And yung isotopes natin, they behave different, no? Than the other isotope. Okay? Some of which could be reactive, some of radioactive, some of them are not. Okay? So another example will be this one, uranium-235 and 238. The stable form of uranium is uranium-238. No? However, in nuclear power plants, they use nuclear-235, okay? Because this is unstable. Okay, so this is unstable, so that's why they use it in nuclear power plants. Ito, medyo stable yan, okay, compared to this one. Okay, so as you can see, they have differing chemical properties, no? Although they are the same elements, no? So that those are isotopes, no? Okay, so ganun. Ayan, so isotopes, atoms having the same number of protons but different number of neutrons, okay? So, ayan. This is for self-checking, no? Ayan. So, kayo na bahala dito. You can answer this problems here. Okay? And then, the answers are written also on the PowerPoint. Okay? So, ayan. So, this is self-check. You can do it at your home. Kayo na bahala dyan. Okay? And then, you can check your answers if tama kayo. Ayan. Okay? So, ganun ha. So, kayo na bahala dyan. Okay? Kasi self-review na lang yan. Okay, so you have plenty of materials to work on so that, ayan, a question. Can elements with more than one neutrons can be synthetically made? Yes po, okay. For example, the elements in the last part of the, of the, pangalan nun, of the periodic table, no? For example, the oganesson, no? Ayan, sandamukal yung neutrons na pinagsama-sama nila doon together with the protons. So yeah, that's possible. Ang tawag dyan sa process na yan is nuclear transmutation, okay? So, how do they differ in properties? When we say property, we're actually referring to their nuclear reactivity, okay? Some of them could be radioactive, some of them are not radioactive, no? So siguro itatanong mo na paano po sila nagiging radioactive? Paano po hindi, no? Okay. So sige, bigyan ko kayo ng idea. Okay? Because I discussed this in my engineering students, no? Okay. Nasa YouTube ko siya actually. You can watch that. Yung nuclear chemistry discussion ko doon. Hanapin ko lang yung PowerPoint. Okay. Paano natin nasasabi that certain nuclear are reactive, some are not, no? Paano kaya ganun? Okay. Ito yon. Teka lang, pull out ko lang yung PowerPoint. So, ito yung discussion ko ng nuclear reaction. Ayan, we have the concept of nuclear stability kasi, no? So, there should be a correct number of neutrons and protons kasi for the nuclei to be stable, no? Okay? So, yan. Pakita ko yung belt of stability. Ayan. So, apparently, as the atomic number increases, the number of neutrons required to make the nuclei stable becomes greater, no? However, may limit yan, no? Pagdating sa part na to, you can no longer create any elements that are stable, no? So that means all those elements beyond that line is radioactive na. Okay? So yan yung idea doon, no? Yes, you can create elements with many protons, and the reason why they are chemically different is because of their nuclear stability. Okay? Kasi yung nucleus natin, may limit yan, okay? If there are too much protons, there are too much neutrons, then they will be very reactive na, okay? So ito yung concept ng nuclear stability. Ito yung sasagot sa question na how do they differ in properties, na, okay? Okay, meron kaming ginagawa dito na proton to neutron ratio, okay? And then with the number of proton to neutron ratio, we can tell anong process yung pwede nila i-undergo, whether they go alpha emission, beta, positron, electron, and gamma emission. Ayun. So there's too much uh, idea na kailangan mo malaman okay? Para masabi mo na ito, chemically different than the other. Okay? Ayan. So inaalam namin yan sa nuclear chem. Okay? So this is actually a very interesting thing, no? Kasi I'm a member of the Philippine Youth Generation for Nuclear Science, no? Okay. Member ako noon. So basically, I just attend webinars about nuclear and nuclear science, no? And apparently, you can also use the idea of nuclear science in your research, no? So ayun, I highly suggest you join yung mga nuclear sessions nila. Okay. Kailangan hanapin ko sa Facebook kasi meron silang sessions eh. You will learn more about nuclear reactions in their sessions, webinars, no? So I highly encourage you to attend, okay? Teka lang ha. PGYN. Ayan, Philippine. PYGN ba yan? Ayan, PYGN pala. Philippine Young Generation in Nuclear. Attend kayo dito. Join kayo. Ayan, may mga webinar sila. So I think this is the latest webinar. Marami kayong madidiscover dito. No? Ayan, dito nyo malalaman why am I an advocate of nuclear power plants. Okay? Kasi we are dying and we need to remove carbon emissions. So that's why we have to go nuclear. Okay, so yan sali kayo dito. Philippine Young Generation in Nuclear. Ayan, so PYGN. Sali kayo dyan ha. Okay, so may certificate yan after the session. And makikita nyo dito na hindi lang siya purely physics and chem. You can apply it in biology, no? Okay, so ganun. Sali kayo dyan. For example, yung mga MRI imaging, no? So that actually uses nuclear science, no? MRI imaging, yung ano pa ba? MRI, yung cobalt treatment for cancer, iodine for thyroid cancer, no? Ano pa ba? Ayun, so many of those things na nasa PowerPoint ko yun eh. Pero yun. Just if you're interested, you can check that. Okay. Anyway, so let's proceed with the second part. Kasi if you are very interested, then madaming mga bagay na kailangan natin malaman. Okay. So anyway, let's proceed. For the second part of our discussion, alam ko suko na kayo. Ang daming idea na. Pero kaya yan na. Let's talk about this one, the periodic table. No? Because we know that atoms, no, yung atoms natin, iba-iba yung elements nila, di ba? Okay. And for every elements, they have differing number of protons, differing number of masses, no? And alam natin that the elements are written in the hindi pala naka-share yung screen ko. Ang laki ng mukha ko na. Ayan. Ayan. So let's talk about this, no? That alam natin yung atoms, iba-iba yung elements siya. And then yung ating elements ay nasa periodic table. Okay? So now let's take a look on how or on ano yung nangyari. Paano tayo nag-come up with this periodic table? No? Kasi alam natin, yan na yung periodic table natin. Pero, let's take again a short history discussion. Okay? Mag-history lesson muna tayo on how we developed this periodic table. Okay? Kasi before, in the early times, no, there are few elements, no? And recently lang to napuno, no? I think that's around 2013. Doon lang napuno yung periodic table. I remember nung bata pa ako, I think 4 years old, 5 years old, grade 1 ako noon. Maaga ako nag-aaral eh. Okay. As early as 3 years old nag-aaral na ako. Kasi wala eh. boring sa bahay, hindi mag-aral na lang daw ako. Ayan. So, ayan, as early as 3 years old, nag-aral na ako, and then 2 years later, I think 5 years old ako noon, grade 1 na ako. Nag-kinder ako eh. So, nung grade 1 ako, um, I really find my subjects boring, no? So, ginawa ko, tumingin ako sa libro ng kapatid ko. So, si kapatid ko, si Sam, he was, I think, grade 4 at that time. So, may science na sila. So, tinignan ko yung libro nila ng science. Okay. Naalala ko yung itsura ng periodic table na eh. Putol. Okay, putol yung periodic table. Okay. So, parang ganyan yung periodic table. Basically, what's missing here is itong mga elements na to. Okay? That was early 2000. Okay? So, 2000, 2001, ayan. Grade 1 ako nun. And then, kulang na kulang itong mga to. As in, wala pa siyang kalaman-laman. Okay? So, nung lumaki ako, over time, nakita ko yung development ng periodic table. Nadagdagan siya na nadagdagan until later on, just within our decade, napuno na siya. Okay? So that is history in action na nakikita ko talaga siya na nagde-develop. Okay? But if you live, if you can live hundreds of years ago, the periodic table before will look very different to what it is today. Okay? So yun yung gagawin natin. Let's take a history lesson muna and see how we develop the periodic table. Okay? So again, in the early times, no, onti lang elements na alam nila. Okay? Mostly carbon and then some metals, no. Okay, bakit may metals? Because they use metals in developing weapons, no, against the enemy at the time. Okay, so let's start with Dube Reiner. Okay, kasi siya yung isa sa mga tao that developed the periodic table. Okay, let's start with sorry, may audio pala. Let's start with Dube Reiner. Okay, ano meron kay Dube Reiner? What Duber-Reiner did is that he arranged the elements in triads. No? Naka-triad siya. Ibig sabihin, tigta-tatlo. So he arranged the elements of same properties, no? Same chemical properties into triads. Okay. For example, the lithium potassium and the lithium potassium. Okay. The lithium, sodium, potassium. When you put lithium, sodium, potassium in water, they explode. Okay? When you put these metals in oil, you produce fats. You produce soap. Okay? So, ibig sabihin, these elements have the same chemical property. So, ginawa niya, grinop niya yun. Okay? Sabi niya, kayo pare-pares kayo na ginagawa. O, pagsasama-samahin ko kayo. Okay? Because when you add it in water, it explodes. All of them explodes. Pag nilagay mo sa mantika, nakakagawa ka ng sabon. Okay? Yun yung ginagamit natin until now in producing soap. Okay? So, yan. So, sabi na Duberainer, since they behave similarly, I will group them into triads. Okay? So, basically, the periodic table at that time is para siyang flashcard. No? Tigta-tatlo yung laman ng flashcard. Okay? And then, something interesting was discovered by Duberainer. Okay? Kasi sabi niya, when you get the average of the first and the third element, you can actually determine the mass of the second element. No? Okay, so for example, the mass of lithium is 6. No? Okay, so 6 yan. For potassium, that is 40. If you get the average, that's 23. And apparently, 23 nga yung mass ni sodium. Okay? So, kumbaga, may napansin siyang trend. No? May napansin siyang trend sa kanyang periodic table. That the average of the first and the third atom's mass, no, is the mass of the second element. Okay? Ayun. So, he grouped them in terms of their chemical reactivity. And then yun, na-discover niya na pag in-average mo yung dalawa, yun yung equal sa mass ng second atom. Okay? So yan, nothing fancy, no? Okay, pero I think this is great for them, no? Kasi they were able to predict the masses of the newly discovered elements, okay? Okay, based on their atomic properties, okay? And then dumami na yung elements natin. So from around 10 elements, no? from around 10 or 12 elements, dumami na siya up to something like 20. Dumami na talaga ito, 20 and above. Okay? So that means yung triad, that is no longer good in describing many elements, no? Kasi hindi na siya by group of threes, no? Possibly by group of four, group of five, no? Okay? So hindi na siya kaya ng triad. So they made a new periodic table, and that is new. So si Newland, shy English person, so he lives in and UK people are very musically inclined, no? So they actually do music all year round, no? Alam niyo yung Mary Poppins, no? Yung Do a Dear familiar, no? So, sa kanila yun. So English people are very musical. And one of them is John Newland. So his knowledge in music actually helped him in creating his periodic table, the octaves. No? In music, alam natin, the first note, the do, okay, or the C note, repeats after several notes. Now, after seven notes, yung pangwalong note, it is just the do, but on a higher pitch, okay? Mas matinis nga lang. So that's the idea of musical staff, 'di ba? Okay? So yung C dito, that is the same as the C there, and the C here, and the C there. The only difference is the pitch, no? So ginawa ni Newlands is that yung pitch, inisip niya as the atomic mass, okay? And then yung notes, inisip niya as the element, no? So what he did is that he arranged the elements in terms of increasing masses, and then napansin niya that when you arrange them in increasing masses, they still group together in terms of their chemical property. Okay? Group niya tig sa 7, no? So 1, 2, 3, 4, 5, 6, 7. Then yung pang 8 element, they have the same property as the previous element. These have the same property as that one. Ganun. Sabi niya, when he arranged the elements into 7 groups, the repeating properties appear again. Okay? So, yun yung octaves ni Newland. Okay, for example, andito pa rin yung lithium, sodium, potassium, which dates back to Dobereiner. Okay? As you can see, magkakagroup pa rin sila, no? By the time of Newlands, nakagroup sila. Okay? So, that's very fascinating according to them. Okay? Sabi na, kakaparin sila ng property, oh. So, yun yung periodic table ni John Lewis, no? He arranged the elements in terms of increasing masses. He grouped them into 7, and apparently the first and the eighth elements have the same properties. So that's why it is called the law of octaves, no? Every eighth element nauulit yung chemical property. Okay? So, yan. So, that's why we call it the periodic table. By the way, segue ako. Periodic table, meaning kasi ng periodic ay repeating property in chemistry. Okay? So, that's repeating property. And apparently, yeah, you can really say that there are repeating properties in their tables. Okay? So, that's periodic. Okay? So, ganun lang. However, ano yung naging problem ni John Newton? In his time, okay, so this is the onset of industrial revolution. And what happened in the industrial revolution? There was a desire to know more elements in nature, no? Because alam niyo na, capitalism, no? Ang gagawin niyan is to extract of the possible materials we can get from nature. Okay? So yun, that allowed scientists to be funded in their research for new elements. Okay? So, ibig sabihin nun, the elements got bigger, bigger, dumami sila, and then hindi na siya kasya sa octaves. Okay? So, hindi na siya kasya sa octaves. So, there's a need to create a new periodic table now which can fit almost all the elements that are discovered. And that is done with the help of Mendeleev, no? So Mendeleev is a Russian chemist, no? Okay, in which he arranged the periodic table the same way the two other people did. Okay, so paano ba nila in-arrange yung kanilang periodic table? By mass and by properties. Okay, so ginawa din yun ni uh, Dmitry Mendeleev. Okay, so he arranged the elements in terms of weight and their periodic properties. Okay? So ginawa niya, he made 18 groups, no? 18 main groups. So 1, 2, 3, 4, 5 to 10. Okay? Okay, so 12, then 13 up to 18. Okay? So, yan. So overall, may 18 groups sa kanyang periodic table. And then, he arranged the elements based on their property. O, tignan nyo uli, oh. Lithium, sodium, potassium, magkakasama uli sila. Okay? So, yan. So, even beforehand, magkakasama sila. Until now, magkakasama sila, no? For example, ito, calcium, strontium, barium. Tignan nyo. Magkakasama sila. Calcium, strontium, barium. Okay? So, as long as you arrange them in terms of their masses and their property, all of them still align, no? Regardless na dumami man yung element or not. Okay? So, yun. Ang nangyari lang is that instead of octaves, nadagdagan siya ng another 10 columns. No? Okay? We call this column the transition metals. Okay? Anyway, so mamaya na yan. So, yan. So, Dmitry Mendeleev arranged the elements in terms of their atomic masses and their periodic properties. And with that, he created the modern periodic table na. What's interesting with Dmitry Mendeleev is that the way he arranged the elements, no, sabi niya, he can predict the properties of the missing element. Okay? For example, gallium wasn't really discovered at his time, no. Wala pang gallium sa time ni Dmitry. So, he called this blank box, no. Tinawag niya yung blank box na yan na eka aluminum. Okay? So, tawag niya, walang element doon. So, sabi niya, tawagin ko na lang siyang eka-aluminum. Okay? And this eka-aluminum, no, ang ginawa niya is that based on its position in the periodic table and its neighboring atoms, no, he was able to predict the density and the appearance of that eka-aluminum, no. And yun, later on, nakita nila yung ano mismo, yung gallium at as it behaves very similarly with gallium na. Napakita ko sa inyo ha. Ito yung mga eka elements that Dmitry predicted to exist and yun, na-discover nga siya that they exist. No? So, eka aluminum. Ibig sabihin, nasa baba ni aluminum. Teka lang ha. So, yan. So, eka aluminum is the element gallium. Okay? Eka silicon, germanium. Okay? So, ayan, Mendeleev's predicted elements. So, ayan. So, belong dito si eka aluminum. For example, ito. Take a look. This is the prediction of Mendeleev, the eka aluminum. And this is the actual property of gallium, the element that is the eka aluminum. Ito yung prediction, ito yung reality. Look at how close his predictions were. Okay? So, napaka-great niya, no? Ang galing-galing niya. Okay, so look at the mass. It's so accurate. The density is very the same. Okay, melting point can be also predicted, no? So, that's how brilliant Dmitry is, no? Okay, so hindi lang yan, no? He also predicted the eka silicon or the germanium and the other elements, no? Eka boron, something. Okay, so the way Dmitry Mendeleev arranged the periodic table is that na-predict niya kasi that there will be more elements in the future. Okay, so he reserved some spaces and then for each boxes na blank, alam niya yung property based on estimations on their chemical groups na. Okay? So, yun lang. So, estimate lang ginawa niya. He was able to predict the properties. And yan. So, that's why Dmitry Mendeleev is the father of the modern periodic table. Na. Okay? Ano namang ganap ni Henry Moseley? The thing with Henry Moseley is that, sabi niya, I think it will be more logical if you arrange the elements in terms of their atomic masses or in terms of their atomic charge, no? So actually he was pertaining to the protons at this time, okay? Pag sinabi niyang charge, he was pertaining to the protons, okay? So sabi niya, it is better, no, if we arrange the elements in terms of their protons, not really the mass, okay? Una siguro para mas madali maintindihan, no? Kasi kapag masses yan, ang numbers natin will be 1 for hydrogen, uh, 4 for helium, 7 for lithium, so on and so forth. No? Jumpy yung numbers. However, if you arrange them in terms of their atomic numbers, it will be in increments of 1. No? 1 for hydrogen, 2 for helium, okay, 3 for lithium, 4 for boron, so on and so forth. Okay? Mas madali siya maintindihan. Okay? Mas madali mag-assign ng numbers. Okay? So yan. So Henry Moseley stated that instead of arranging the elements in terms of their masses, you arrange them in terms of their protons, okay, or in terms of their nuclear charge, na the protons, because that is the reason why we see similar properties. No, that's the reason why we see periodic properties in the periodic table daw. Okay. So, ito daw yung dahilan sa periodic properties, sabi ni Henry Moseley. Okay? So, yun lang naman yung ambag niya. Okay? Okay? So, now, we have the modern periodic table. All of them are completely filled. Siguro, you may ask, no, that is it possible po that we discover more than 180 elements? The answer is yes. There's no limit in science except for Heisenberg uncertainty. Walang limit when it comes to big objects. Pero kapag small object, may limit. Okay? Yan. So, that means you can really combine the nuclei of different atoms. Pwede mo sila pagsama-samahin to form heavier elements. Okay? So, ganun. There's no limit. That means if may discover pa tayong new, pag may ma-discover pa tayong new elements, ano kaya gagawin nila? Siguro ilalagay nila yun dito sa baba. Hmm. They can create column here. Ilalagay dyan sila sa. But for now, those heavier elements don't actually have practical application. That's why we are not really that much interested with them. I'm skeptical if mag-discover pa sila ng kasi etong mga to wala naman yung mga practical applications. Okay? Elements. They don't have practical application. Okay? So anyway, going back to the periodic table, this is how the periodic table nowadays looks like. So as you can see, there is a great divide in the periodic table. So if you cut this, uh, makikita nyo that the periodic table is separated into three distinct portions. The one on the left are the metals. And we know that metals are shiny, they conduct electricity, they are malleable. That's why people use this to create swords, to create armors, to create buildings. So yan yung ginagamit nila. Okay? Because these elements here are very strong. In between them, you have the metalloids, which has both properties of metal and non-metal. Okay, we know that metal conduct electricity, non-metals do not. Okay? But for metalloids, they are in the borderline. Okay? And being in the borderline is not actually a bad thing, no? Kasi apparently, we benefit from the metalloids, no? Such as silicon. Okay, so silicon is the widely used semiconductor metalloid that we use technology na. Our laptops have them, cell phones also got them. Itong aking webcam, may silicon yan. I think itong silicon graphics tablet, meron. Okay. So almost all na that involves technology, may silicon yan. Okay, so again, being in the borderline doesn't mean that wala nang sabi. No, no. Actually, mas nagagamit nga natin to kaysa sa iba, di ba? Okay, so yan. This gives us technical advantage over other. Bakit kaya hindi metals yung ginagamit sa semiconductors, no? Okay, bakit kaya hindi metals na lang yung ilagay sa processors, no? Kasi, um, what we actually use, di ba, sa technologies that we want our data to be streamed in bits, no? In bits of 1 and 0. So kapag 1, ibig sabihin the electricity is conducted. Pag 0, it is not conducted. If we use metal kasi, this 0 will be impossible. Okay? Ayun, so it will be always 1. It will always conduct electricity. However, we want to transmit bits of data in 1 and 0 in binary. So we need to use metal bits because sometimes metalloids allow electricity to pass through, sometimes they do not. Okay? So binary yung nagagawa. Okay? Kasi kapag metal yan, all one yan. Lahat ng kuryente dadaloy. Anyway, IT people can answer that more accurately, but it's the idea. Okay, and then for non-metals, these are the elements that doesn't behave as metals, and mostly of them are found in gaseous phases or liquid phase. Okay, ito naman mga solid phase tong mga to. Okay, so all of these are solids. Ito naman mostly liquid and gas sila, and then the metalloids are solids. No? Solids tong mga to. Okay, so ayun. Another interesting here is the position of hydrogen. Okay. So in reality, yung hydrogen, hindi talaga dapat yan dyan. Okay? So, dapat ang hydrogen ay nasa, nandun sa tabi ni helium. Okay? Kasi, take a look at the periodic table given to us by 11 na pala. Bibilisan ko na lang. Given to us by Newlands. No? The hydrogen is matched with fluorine. So that means the hydrogen should be here. Okay? Hydrogen should be here. Pero bakit kaya nila nilagay doon, no? Okay? One probable answer is the electron configuration of the um, of the hydrogen. No? So apparently the electron configuration of the hydrogen is 1, okay? So yun. Kaya dyan na lang nila nilagay. Okay? So yan. Dyan na lang nila nilagay. Pero in reality, it should be placed here, no? Because the property of hydrogen resembles this group. No? But for practical reasons, in terms of electron configuration, dyan na lang siya. Okay? So again, the behavior of hydrogen is very different to the others in the group 1 because it doesn't really belong there. Doon dapat siya. Okay? But to create balance, doon na lang siya nilagay para aesthetically pleasing sa mata. Okay, a review question. John Newlands and Dmitry Mendeleev are both famous for their work assembling the periodic table. Ano daw pinangalan ni John Newlands sa kanyang periodic table? Okay, so obviously that's the octaves. Okay, huwag niyo kalimutan yung mga name ha. As Dmitry Mendeleev arranged the elements into in his periodic table, he realized that some elements were yet to be discovered, so he left gaps for them. The patterns in this table allowed him to, sinabi ko na to, okay? So, there are elements that were not yet discovered at his time, so he left gaps and pinangalan niya yung eka elements. No? Yun yung mga eka elements. Okay? I don't know what's eka, pero yun, eka elements. So yan, yung eka elements, he was able to predict the properties of those elements. Okay? Yun. So that pag na-discover siya, it will have the same property as what he has predicted. Okay, elements in Mendeleev's table were ordered in terms of atomic weight. What are the elements in the periodic table ordered by? Okay, so basically, we follow Henry's mostly idea na that the elements should be arranged in terms of their atomic number or the number of protons. Okay, so yan. Starting with the earliest event at the top, sort the key events in the history of periodic table. Madali lang yan. Konti lang kasi tao dito. Then we have Dubé Reiner, then followed by Newlands. Okay, so yan, Newlands, followed by Dimitri, followed by the addition of Moseley's idea, and then the periodic table, the modern ones. Okay? So, ganun lang. Okay? So, onting tao lang yan. So, it will be better if you memorize them. Okay? Ayan. Okay. So, now, let's go to the last part. Ito, last part na to. No? So, this is just very quick naman. Okay? So, let's talk about the periodicity or the periodic trends. Okay? So, I will discuss one of them and then later on, let's relate the other periodic trends with that trend. Okay? So take note that the way they arrange the atoms in the periodic table is based on their chemical properties or their periodicity. Okay? So yun yung concept nila starting from Dubé Reiner up to Dmitry Mendeleev, di ba? So they arrange the periodic table in terms of their chemical property and increasing atomic mass or atomic number. So little did they know that the way they arrange the atoms also tell us about some periodic trends, no, that are not seen by their eyes before. Okay, kasi ngayon we can see the atoms well, no? We can really see the atoms with the help of technology, no? Okay? So dati hindi nila nakikita 'yon, okay? So scientists found something interesting with the way they arrange the periodic table, okay? For example, in terms of atomic radius, ganito daw yung trend in terms of atomic radius. As you go to the left, it increases. As you go down, it increases. Let me rationalize on why that is the trend, okay? So let's take a look at the at this trend, no, yung pababa, no. As you go down the family or as you go down the group, the size of the atom increases or the atomic radius increases. Why is that so? Okay. So let's use Bohr's idea. Okay. Let's use the Bohr model. Sabi natin that electrons occupy certain orbits, di ba? Certain orbitals. So that means as you go down the periodic table, the number of electron increases. So as the number of electron increases, the size of the radius or the size of the orbit also increases. Okay? Lumalaki din yung orbit, no? So that's why the atoms here are smaller than the atoms here. Okay? So yun yung trend, no? Because as you go down the family, as you go down the group in the periodic table, the radius or the distance of the atom and the electron increases because they occupy now bigger orbitals. Okay? So yan, we use Bohr's logic for that. Okay? So that's the explanation. Dumadami yung electron as you go down. However, let us rationalize why the trend for increasing atomic radius is going to the right. Kasi 'di ba, ang logic 'pag up to down, dumadami electron as you go down. So yeah, it's true. However, take note that as you go to the right, the electrons also increases, right? The number of protons and electron also increases. Bakit yung trend baliktad, no? Ito yung pinagtataka ko dati, no? Kasi nung tinuro sa amin 'to, third year high school ako, hindi ko na-gets bakit as you go to the right, lumiliit. As you go to the right, lumalaki yung atom. Ang nasa isip ko nun is as you go to the right, dumadami electron eh. So dapat dito yung malaki yung ano, dito yung malaki yung atoms. But no, that's not true, no. The opposite is true. Bakit kaya? Okay. Let's rationalize on Bohr's model again. Okay? So, let's talk about this particular family here. And this row here, this particular row here and here now. Okay? So for lithium, we have to for lithium row, ayan, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay? Yung row na yan, they will occupy this orbital only, the second orbital, okay? The second energy level. So ibig sabihin, every time you add electron, they will only be located on the same orbit, okay? All of those 10 electrons that can be accommodated by the second energy level, dyan lang sila, iisang orbit lang sila. The problem is, as you increase the number of electron, the number of protons also increases. So that means, since mas marami ng positive banda dito sa right side, it pulls the orbit in reality, no? Hinihila niya yung orbit, no? It makes the orbits smaller kasi the nucleus, no, becomes more charged, no? Mas nagiging positive siya as you go to the right, no? So yeah, the logic is correct, no? The electron increases. However, they occupy the same orbit. So ibig sabihin nun, dumadami man electron mo, nasa iisang orbit siya, so that kapag na-impluwensyahan yan ng ano, ng nucleus, mashi-shrink yan, ma-attract yan towards the center. So that's why the atomic radius decreases to the right, no? Because dumadami yung protons doon, lumiliit yung orbit kasi na-attract sila sa nucleus. Okay? So napupush sila inwards because of the increasing protons. So yeah, dumadami electron, yes. However, they are on the same orbit. Dumadami yung proton, that's why napupull yung orbit. So that's why as you go to the right, the atomic radius decreases. So that means as you go to the left, the atomic radius increases, okay? Because there are lesser charged particles in the nucleus so that the electron will be farther from the nucleus, okay? So yun yung logic behind that, no? Kasi dati, nagtataka talaga ako, no? Bakit ganun? Okay? But yeah, that's the reason why the periodic trend is that, no? As you go down, the orbits increases. Okay? Yung orbit yung dumadami. That's why lumalaki talaga. Okay? Then as you go to the left naman, the charge of the nucleus decreases. So that's why the distance of the orbit is bigger. Okay? Kasi kapag masyadong maraming positive sa nucleus, mag-shrink yung orbit. Okay? Because the electrons are attracted to the nucleus. So that's the reason why the atomic radius trend looks like this. No? It is increasing as you go down and increasing as you go to the left. Okay? So yan. So with that logic, we can explain other periodic trends such as the ionization energy, electron affinity, and electronegativity. Because these three other periodic trends has something to do with the electron. Okay. So again, yung logic natin dito is that the distance of the electron to the nucleus will help us answer these three trends. Okay. So let's talk about electron affinity. Electron affinity refers to the attractedness of the electron to the nucleus. No? Kaya nga affinity, no? Affinity. Yan yung attraction of the electron to the nucleus. So, between the two atoms that I will draw, sa tingin nyo, sino sa mga electron na yan yung mas attracted sa nucleus? Obviously, ito dapat, di ba? Kasi bakit? Mas malapit siya sa nucleus, okay? So, the logic here is that the smaller the atom, the greater the electron affinity. Why? Because it is closer to the positively charged nucleus. Remember, negatively charged particle loves positively charged particle. So that means the closer you put your electron to the nucleus, the more attracted they become. Okay? So that's why the trend is opposite of the atomic radius. No? The smaller the atom, the greater the electron affinity because the electron is now much closer to the nucleus. Okay? So that means the bigger atom will have lower electron affinity. The smaller atom will have the greater electron affinity. So that's why kabaliktaran yung trend. Okay? 'Di ba pag atomic radius ganon. Now, kapag electron affinity, ganito yung trend, no? To the right and pataas. Okay? Kasi as you go to this atom here, they are smaller. That's why they love electron. And that's the reason why they are non-metals, no? Because non-metal tend to accept electrons. The metals release electron eh. Okay? Kasi masyado silang malaki. Hindi na nila mag-grasp yung electron. Ang laki-laki nila eh. Okay? So that's why pinapamigay na lang nila yon. So that's why the elements here are metals. However, the smaller your atom becomes, the more chances for it to be non-metal. Kasi masyadong madikit yung electron to the nucleus, so they are attracted to each other. So yan, that's why they are non-metals. There, ito ay mga metals. Okay? Ayun. So that's the trend, okay? That's the first trend, electron affinity. Ionization energy also works on the same principle. Okay? The bigger the atom, the easier for it to be ionized. Therefore, the lower the ionization energy. Dito low yung IE. Okay? However, the smaller the atom, the bigger the IE, the ionization energy. What is ionization energy? Okay, ionization energy is the energy that is required to pull the electron away from the atom. Okay, so let's follow the logic of the atomic radius. Okay, so between two electrons, sino mas madali kunin? Itong big or itong small? The answer should be the bigger one. Mas madali to kunin because again, we consider the distance. The farther it is from the nucleus, the lesser the attraction between them. Therefore, mas madali siya kunin. Okay? Kaya ang logic ko dito ay LDR. Okay? Alam niyo yan, long distance relationship. As for some people, it doesn't work. Ano yung reason nila? The reason it doesn't work is that yung attraction kasi, kapag masyadong malayo kayo sa isa't isa, parang nagde-diminish siya, no? Kasi hindi kayo nakikita always, di ba? So, ganun yung kaganapan sa love life. We can relate that to electrons, no? The farther the electron is to the nucleus, the lesser attracted it becomes over time. Hindi na siya attracted sa kanya. So, that's why madali na siya kunin ng iba. Okay? So, mababa yung kanyang ionization energy. Madali na lang siya kunin. Okay? So, yan, malungkot na siya. Okay? Kasi nawala na siya ng electron sa labas. Okay? So, that's the idea, no? LDR. Okay? Yan yung aking logic dyan. If it will help you in memorizing this, then use it. No? Pero in my case, yan talaga yung ginagamit ko. So, I will not forget the periodic trends. Okay? Pag masyadong malayo, hindi na attracted. So, madali kunin. Okay? However, if the electron is closer to the nucleus, masyado silang attracted to one another. Okay? So, ibig sabihin, mahirap kunin yung electron. Okay? Mahirap kunin yung electron. So, that's why it will have higher ionization energy. Kumbaga, kailangan gumawa ka ng big eksena pa before you get the electron. Okay? So, that's the idea. The bigger the atom is, the lower its ionization energy. Therefore, the easier for you to get the electron from the atom. The smaller the atom is, the higher the ionization energy because the attraction between the electron and the nucleus is intense. Okay? Yan yung sasabihin kong word, intense, yung kanilang attraction kaysa dito. So, just use the LDR logic. Ginagamit ko rin yan dito. Ayan, LDR lang din yan. Pag masyadong malayo, hindi na attracted. No? Pero kapag magkatabi lang, attracted. No? That's why probably some of you, no, beto based on my experience no, sa classroom namin, no, mga classmates ko, since always magkakasama sila, sila magjojowa. Okay? Hindi na sila tumitingin sa ibang section. Okay? Ganon kasi nangyayari na. Baka mamaya may mga post na diyan sa ano sa 1FEU o kaya sa mga Freedom Mall, no. 'Di ba nakikita niyo yung mga post na bawal po ba ma-in love sa blockmates? Gamitan niyo ng periodic trend 'yan, no. The logic here states that the closer you are to one another, the more attraction could possibly arise, no. Okay? So, yan. So, yun yung concept ng LDR sa lesson natin. Last one, electronegativity. So, electronegativity works on the same principle as electron affinity, no? So, electronegativity is the tendency of an atom to attract electrons. So, very similar with electron affinity, okay? So, ganun din yung trend niya. Of course, the smaller the atom is, the more tendency for it to attract the electron. Sa prof po, babawal. Ay, nagbabawal yan. Ayan. Anyway, bawal yung kapatid. Anyway, eto, ayan. As it works on the same principle as the previously described electron affinity, no. So the electron, as it comes close to the nucleus, the more attracted they become. Okay. Kaya yun, atoms here are more electronegative than here. Okay. So napapansin nyo, no? Basta kabisado nyo yung atomic radius na trend, pwede nyo na ma-relate yung ibang trend, di ba? Okay? Just use the LDR logic, no? Kasi electron yung usapan dito eh. Okay? So, kabisaduhin nyo lang tong atomic radius, then yung opposite nun, that will explain the other three trends. Okay? So, ganun lang. Kaya nga sabi ko sa mga students ko, do not just memorize, no? You have to think of relating this to some nonsense sa buhay. Ako minsan nire-relate ko yung yung lesson sa sa love life, no, sa kung ano-anong makita ko sa paligid, no? So that I will easily recall that, no? Kasi yung utak natin, I don't know why it is designed to retain nonsense info, eh. Hindi ko alam bakit gano'n, no? Yung mga hindi hindi important, yun yung maalala natin. So that's why, ang gawin niyo is that you relate the lesson to those things that are ridiculous, no? Kasi maalala niyo siya in the end, okay? Pag ni-relate niyo sa gano'n. So that's why the logic here is LDR. So you will use it in determining the periodicity. Okay? Ayan. Comment niyo. Yari tayo dyan. So yan yung trend, ha? Okay. So again, the bigger the atom is, the lesser the attraction of electron. Therefore, the easier it is to pull out. Okay? The smaller the atom is, the more attracted the electron is. That means the harder it is to get. Okay? So, ganun. So, yun yung logic dito. And then yung electronegativity, this works on the same principle as electron affinity. Okay? Ito, the laboratory prof will discuss this, yung ating electron configuration. Okay. The only important thing here is that kapag marunong na kayo nito, I hope na na-discuss na to sa inyo. Okay? As you can see, depending on the group they belong in the periodic table, they will have the same last electron. Okay? For example, lithium, sodium, potassium, S1, S1, S1. Okay? Yun yung ending nila. Okay? For example, sodium, yeah. So yun yung mga last nila. I don't know what is this for, but kaya nilagay yan. Okay, so basta yan yung idea, and that will be discussed deeply in the laboratory. So I hope na discuss na sa inyo. Okay. This is problems for self-check. Ayan, try to answer the following items. Ito yun. And then all the answers are posted here naman. Okay? So kayo na bahala mag-work on them, ha? So I trust that you can answer those problems naman. However, if you still have questions, do not hesitate to ask me. Okay? Because my lines are always open. No? Pag gising pa ako, I will answer your questions ASAP. We're almost time. So yan. So tapos na tayo sa lesson. We are done with chapter 2. Ibig sabihin, malapit na tayo sa midterms. No? Parang kamakailan lang fresh uh, excited pa kayo sa FEU ngayon. Hindi na kasi may exams na kayo. Malapit na. Okay, so this is the periodic trend. Again, look at this, no? Atomic radius increasing dito. Pero opposite nun yung mga trends for electron. Affinity, ionization. Okay, so as you can see here, metallic character increases as you go here. Kasi nga, mababa yung ionization energy nila. For metals kasi, the electrons are easily transferred. No? So, ibig sabihin, mababa yung ionization energy nila. Kasi yung electron, madali kunin. So, that's why they are metal. And the elements here are non-metals because they don't like giving off electron. Okay? So, that's why they are non-metals. Okay? So, yun. And then yung mga non-metals natin, they are the borderline. Sometimes they give off, sometimes they do not. No? So, that's why we use them in semiconductor. No? To transmit the ones and zeros. Okay? Pag 1, ibig sabihin may conduction of electricity. 0, ibig sabihin wala. Okay? So, that ends our discussion for this day. No? Ang dami, no? Do you need to memorize all of them? Hindi naman. Just be familiar. Okay? So do you happen to have any questions or we are done? Okay? So again, use some logic, ha? Especially yung LDR, sana magamit nyo. Okay? Kasi kapag kinabisado nyo lang yan, wala. Okay? So I hope that I gave some clarity to some things na might confuse nyo before. Na sana nabigyan ko ng justice yung aking mga pinagsasabi kanina. Okay, so with that, I think if you don't have any questions, then we're good to go. Na? By the way, I would like to request you to um, just be safe. No, we reached 2 million cases, and a few thousand of them ay active cases na. So, and recently the WHO announced that the most prominent strain of the virus here in the Philippines is the Delta variant, okay, which is more infectious. So yan, mag-ingat na lang muna, okay? Kasi kita pa tayo sa face to face. I don't know if that's next academic year, but no. Pero yeah, we'll see each other in FEU, na. So for now, just stay safe, na. And if you are experiencing some symptoms, pwede kayo magpa-test sa remove ko screen sharing. Pwede kayo magpa-test sa sa Red Cross. Okay, so saliva test, that's 2,000. Kung gusto nyo i-deliver yun ng angkas, that's 2,250. Okay, and that is only available for certain cities in the Metro Manila, no? Especially in the central Metro Manila. Okay, for now, just be safe na lang, okay? Kasi uh, we are in a hopeless situation in the Philippines. Okay, mag-ingat na lang muna, no? And let's pray for things to get better. Okay. So with that, so thank you, and I'll see you again next week. Na. So bye bye. Enjoy your Fridays. Na. Enjoy the rest of your day. Bye bye.
Thank you po,
Thank
sir.
you po,
Salamat po,
sir.
sir.
Bye,
Thank you
sir. Thank you
po.
po.
Thank you, sir.
Bye bye.
Thank you po, sir.
Thank you, sir.